Okay, now this is the one I really want to go over. Now you didn't actually have to create the rule here, but I think it's important to know how to do that too. So you can read what the student wrote. Now this was common, so the common issues about these type of piecewise functions and misunderstanding domain and range issues. So you look at this, you say, oh wait, there's three pieces. Okay, so answer's three. That's true, that is what you see, but reacting to what you see may not necessarily be correct. And as humans, we do that. It's instinctive. We cannot help it, right? It's part of our inherent wiring. So you got to kind of train your mind to try to understand the nature of the problem. What is it you're being asked? We're looking for the stated regions of the range. Okay. So there are three regions for the domain, but there are only two regions for the range. So the answer would be no. Okay. Now, there's two regions for the range because it is true that the largest possible value up top would be getting to 6, and the smallest possible value in the bottom would be getting to 2. But notice there's a region in between where there's no valid value. So there's a gap between the top range region and the bottom range region, right? And notice that's true for the domain. There's gaps in the domain between the largest number on the right and the smallest number on the left. So another issue is there's this open circle right here in the middle of the bottom range. And so some people might react to that, think, okay, it can't be valid when y is 0. But keep in mind, as long as you have a valid location on this entire graph for y0, then it is part of the range. And so over here, there is a valid part of the graph in y0. So when you state the overall range of the function, you have to include 0 in this bottom range. But if you state the range for each individual domain, when you get to this far right domain, then this range for that domain doesn't include 0. So that would be a sub-range, which is only specific to this far right domain range. Okay, so I'm going to go ahead and show y'all how to state this piecewise function more formally, again, because it's kind of important. And then that's about all we're going to do today. You guys have the rest of the class. So in general, the format is you have a rule, and that rule maps a domain to a range. And so this is the general process. And so first we'll go ahead and create the correct domain range intervals, and then we'll go back and associate each part of the piecewise function with a rule. Okay, so with this first domain interval, we have from -6 to -3, and notice we got the closed circles, so that means we'll use the brackets. And so that domain interval maps to the range of this left piece, which should be from -2 to 2. And again, those are valid values, so we will once again use the brackets. So we'll have something like that. Okay, now the next domain interval, that would be from -2 to -1. And if you look, you got the open circles. So that means we're going to use parentheses. And so the middle domain interval maps to the range interval from 5 to 6. And again, open circles imply not equal to, so we use the parentheses again. And so this domain interval for the middle piece of the function maps to that range interval. Okay, and then the last domain interval, the one on the right. On the left, that starts at 1, but it can't equal there, and ends at 3, and it can equal there. So you're going to have parentheses on the 1, but brackets on the 3. Okay, and then since this piece only has a range in this sub-range of the bottom that starts at 0 but can't equal 0 and goes up somewhere over here between 1 and 2. Okay, so I'm going to leave that blank because what this value is for the range when the x is 3, that's going to depend upon what function we're using to represent this piece. What's the rule we're used to represent this piece? Okay, so we'll go ahead and get this last y once we decide which rule we're going to use here. Because right now, we know it's in between 1 and 2. That's about all we're going to be able to do. Well, what rules could we be using for these? All right, well, the one piece on the left, this looks quadratic. This looks like a parabola. And so notice the vertex of this parabola is -4, -2. Also, notice as you go to the right, you go up 1. And that's true as you go to left. Oh, so that means the a value is 1. So we can create that rule. The middle piece, this is linear. It's got a slope of -1. And if it continued, it'd cross the y-axis at 4. So we can write these two rules because we recognize that, what am I trying to do? We recognize that one of them is related to a parabola where we have a vertex and we can determine the a value, and the other is related to a linear rule. Okay, so then this would be the linear rule, and then x plus 4 squared, and then -2. You could use vertex form. And technically, people like to put colons here. If you just want to draw a straight line, if you want to organize it another way, I mean, it's not that big of a deal. Now, as I was saying earlier, the endpoint here for the y, we're going to have to decide what that is once we determine the rule we're going to use for this interval. All right, well, let's look at that again. Let's see what we could use. Well, it looks like it starts here at x1, and it's associating a y value 0 when x is 1. Well, that's a logarithm. The log of 1 is 0. Okay, that'll work. Well, let's see. If we went to the y value 1, that means we would have an exponent of 1. And that happened when x is 2. So this is a log base 2 because we get a y of 1 when x is 2. So one of the rules we could use is log base 2. And then the rule would have the x as the value. What else could this be? This could also be a square root. Because normally this would have been at 0, and then the square root of 1 is 1, but it's shifted. So it's got a horizontal translation, and when you go over 1, up 1, this function is going to produce a y of 1 when x is 2. Right? So the square root of 1 is 1. So we could also use for this a translation of 1 to the right of the square root function. So x minus 1. Right? And notice if that's what we did, when x is 2, this becomes the square root of 1. So both of these match those two locations where we know an exact value. All right, so now we can determine what this would be for the endpoint depending on which rule we use. All right, so what's this going to be? Well, when x is 3, that would be for the log rule, log 2 of 3. And when x is 3, if we use the square root, that would be for that rule 3 minus 1, so we get the square root of 2. Okay, so we have our piecewise graph. We detailed all the intervals for the 3 pieces of the visual display, and then went ahead and created the 3 rules. For the last rule, there was 2 possibilities.